Hello, everyone. This talk is about exchanging data between HDFS and RDBMS systems. My name is Praveen. So I'm going to cover these 5 points in this presentation. Most importantly, I'll touch base on 1, 2, and 3. 4, 5 are kind of references for this presentation. The first point, a little background about this point is, as we all know that Hadoop-based ecosystem and its technologies are going rapidly fast, and there are many questions which are popping around, such as, for example, is Hadoop the next generation of storing and retrieving databases? Or the other question could be, is Hadoop going to replace the relational database technologies? Things like that. But for the context of this discussion, which is exchanging the data, I choose to answer whether the relational databases are going to die. If the answer is yes, then probably we need a data transfer just one way, which means from relational databases to Hadoop world. And if the answer is no, then we need the data transfers between the two systems to and fro. So, and the point number 2 is about the tools and technologies that are existing in today's world to do the data transfer between these two systems. And point 3 will touch upon one quick demo, and then we'll jump on to the next point. So the answer is no, right? So this is a fact that we all know. But to make this fact more effective, let's recollect some of the known things that we know about relational databases. That we all know that these systems are there for decades, and they gathered so much of information and data in terms of assets, right? And there are a lot of other factors which we all know that these are not at this point are not directly supportable by Hadoop-based technology, right? So with that, we have to continue relational databases for quite some time, or maybe continuously, right? So the, with the invention of Hadoop, there is a lot of potential um, for rethinking the systems which are earlier have no choice than to store data in relational databases. Now we have a lot of other choices to rethink and design much better way of storing the data or retrieving the data. So out of all this, I would like to touch base on one quick point on whether on point number 3 in Hadoop, which is uh, whether the organization have to rethink about the way that they store the data for their data warehouses. And the answer would be yes, right? Because today, if you look back, the warehouses are stored with the relational database technologies, and they are not much cost effective when compared to the Hadoop way of storing the data warehouse systems, right? So this leads to I mean think about restructuring or redesigning the data warehouse systems, and which will give the necessity for these two systems to talk each other in much interactive way, and and this topic would I feel that this topic would help in answering those questions, or answering the choices that we have for data transfer. Okay, so based on this, the conclusion is yes, these two systems are very much important, and they have to go hand in hand uh, to call it as a modern enterprise solution, um, in my opinion. Okay. Next, we'll look into the tools and technologies that are available for this data transfer. Okay. There are many tools which are out there in the market, but out of which Scoop is definitely on the top, which is actually an Apache community project. From a commercial perspective, our proprietary tools, um, there is a new technology or new way of data transfer coming up from Microsoft PDW, which is poly-based technology. And similarly, Greenplum recently released Hawk as their proprietary way of retrieving data between Hadoop and their appliance. Okay. So apart from that, there are other tools which would help data to move from Hadoop to the existing applications, which is high ODBC drivers, which is very popular in retrieving the data from Hadoop-based systems into any of relational or, for example, an Excel-based environment. So in fact, in one of the demo, so we will look into how to get the data from high ODBC to into an Excel spreadsheet. Okay, and there are other ways of moving the data, which is cascading .jdbc, cascading DB migration, and there are also some other frameworks that are there to do this exchange. Okay, so since Scoop is on the top, so we have to look into what is Scoop and what is the architecture that this Scoop is built on. Okay, so looking into the Scoop, Scoop is basically a tool that would transfer the data. I mean, I would say that would bulk transfer the data between these two systems. So from an architectural perspective, Scoop is a connection-based, plugin-based architecture. There are many applications that might need to interact with Hadoop systems. So there is a necessity to design a new extension or new plugin for a different type of application. So that's the reason the architecture principle of choice is extensibility. Okay, and the other thing is Scoop is designed with JDBC. When I say JDBC, it's JDBC to connect to the relational database world. And on the other side, I mean the Hadoop world, it uses MapReduce framework to interact with the HDFS system. We have Scoop version 1 and we have Scoop version 2. Okay, so version 1 architecture is you can see on the right bottom corner. That's the version 1 architecture. So basically, it depends only on map task. So there is no reduced task for version 1 architecture because the data, if you think about when we interact with a database to send or import or export data, the typical queries would be select star from, okay, or select specific columns from, or select with some where condition, right? I mean, there is very less use case where we aggregate the data on the source side and pull the data into the destination side, right? So that is a separate topic of discussion, so which would be handled with probably with a separate MapReduce kind of a job. But as a tool, if you think about Scoop as a tool, this is meant to data transfer between these two systems. I mean, so the version 1 architecture was designed just with map tasks, which can serve the purpose, right? Scoop can read or write data only to HDFS, Hive, and HBase systems. So that's the limitation that was there in version 1. And the other thing is Scoop version 1 is a CLI-based interface, which is command line interface. So in some ways it is good, and some ways it may not be, but that's how it is designed. So moving on to the next slide. So this is how the logical view of the scoop architecture and the data transfer happens um, from Hadoop and to relational databases. So on the left side, you can see this is a import into Hadoop environment from relational database systems. That is scoop import. On the right side, we can see it's in scoop export, the opposite way. So we can take the data out of Hadoop systems and write that data back into relational systems. So that's the high level view of the data transfer and how it happens in Scoop. Okay, so that's one choice for our today's talk. And since there are some challenges which I briefly addressed in the previous slide, that Scoop 1 has its own set of limitations and which are actually not the context of this discussion, but I have provided certain links where you can go into and see more in detail what are the real challenges that are faced in Scoop 1.0 and which are kind of addressed in next version of Scoop, which is 2. So to talk about Scoop 2.0, let's look into this architectural diagram. So it's no more a client-only architecture. So previously, if you see, it's a client-based architecture where you have to install Scoop and its relevant echo-dependent software on the machines that you are trying to access. But in this Scoop 2.0, it was made more like a server and client-based architecture where you install the software on one particular server, and the client can interact from even from a browser or something, things like that. Okay. And the other major change is on the introduction of the reduced task. So now Scoop is no more a map-only task. It now uses map as well as reduced tasks for the data transfer. Okay. So another very important change is on the JDBC way of restriction. Okay. So previous to 2.0, which is version 1.1, we saw that the Scoop is tightly coupled with JDBC way of connecting. But now you can write your different ways of connecting or your own way of connecting to database without depending on JDBC. Okay, and coming to the security, there are a lot of concerns in security from Scoop. So so Scoop 2.0 addresses that problem as. Okay, so next we'll look into a quick demo with Scoop, and let me jump onto my demo screen. Yeah, back to the demo. If you see the left-hand side, I have a window which is a virtual machine. I install here Cloudera Quick Start virtual machine. So basically, this comes with all the prerequisite software that are required to connect to external systems. Basically, Scoop is installed on this virtual box. So that is the choice I made. But you can install Scoop separately, which is available from Cloudera website or from Apache. Okay. So what we're going to do here, so I'll take a simple example, right? So assume that we have a table in relational database system. Here I'm choosing SQL Server as my relational database system on the left. And I'll create a table here, a simple, very common table, employee table with the predefined columns you can see here. And then insert few rows into this table, and the goal is to transfer this data from SQL Server into Hadoop. There are a couple of options we have, as we saw in the slide, is you can import the data into HDFS as a raw files, or even we can import data into Hive or HBase. So for the purpose of the demo, I'm choosing Hive here. So I'll import the data into Hive, and we'll see the data transfer from SQL Server into Hive. Okay. So this is the table that I'm trying to execute. I'll create a fresh table here. If the table already exists, I'm going to drop that and then insert few rows into the um, SQL Server table. So this script will insert the data into the table. And now let's quickly see what is there in the table. Yes, we can see there are 14 rows in SQL table, which is employee EMP table. Okay. So coming back to Hive console on the right. So let's quickly check whether this table exists, and if it exists, what is the, sorry, what is there in the table. So I'm quickly checking that in the Hive. So in fact, for the purpose of this demo, I actually explicitly deleted if I have run anything in the past. So you can see a message there, the table not found EMP, which is good. Okay, so let's run the command for the scoop. Before we do that, let's quickly check whether the scoop exists. So we all know that which scoop. Yes, scoop is installed on this machine. Clear. Okay, and just to save time, I have the command copied here. But let's quickly look into the command. So you can see that it's a scoop import, and the connection is the JDBC connection string to my SQL Server database, and the database name here is Hadoop and the SQL Server side. So I just chose Hadoop, and the table name that we see here is EMP. Table is EMP, and it's a Hive import. And there is another option that we mentioned: if the table already exists, override the table. Okay, so let's run this. What's happening behind the screen is it's going to connect to the SQL Server database with the connection string that we provided, and then get the data, and using the map job, it's going to take this data into Hadoop, or even in fact it's in this case Hive tables. So let me pause the video, and then I'll come back if once the job is complete, just to save time. Okay, now the job is complete. You can see the job successfully completed in certain time. Now let's see if the table populated correctly. So let's start from EMP. I'm running this command from Hive. So we can see some data there, right? So see here 14, that's the employee number. So we have 14 records in SQL Server. So this is how we transfer data from SQL Server environment to Hadoop Hadoop system. Okay. So let's go back to the next task is how do we transfer data from Hadoop into SQL Server. Okay. So for that, for the sake of simplicity, we'll use the same employee table in which we just created in Hive, and retrieve that back into SQL Server into a different table. So let's create a new table in SQL Server. So employee table from Hive, if it makes sense. Okay. So I deleted the employee from Hive table in SQL Server if at all it exists, and created some structure which is similar to what we are going to retrieve from Hive. And let's quickly run and make sure that there is no record. So basically there won't be any records there. So next we'll jump on to the scoop command terminal window and copy the export command which I already have in the text file. So now we can see the job started. Hopefully it won't take much time, but for the sake of time, let me pause the video and get back once it is complete. Okay, so now the job is complete and the data is transferred back to SQL Server. So in fact, I'm not using any where conditions here, so we should expect the same 14 records back into SQL Server into a new table, which is EMP from Hive. Okay, so let's run this and see what happens. There we go. Okay, so now we have all those 14 records back into SQL Server. Let's quickly compare these two so that we know that exactly what data went into Hive and what data came back from Hive. Okay, let me select both this and run, quickly run, and we should see exactly the same data. Okay, so this concludes the demo on how do we use Scoop to transfer data between Hadoop and relational database system. Okay, so let me jump onto the demo slides. So the next thing we'll look into it is the polybase technology from Microsoft. Okay, so let's quickly look into what this polybase technology is all about and how it is architected. As I mentioned in the previous slide, it's a proprietary technology. If you see the diagram on the left, so a SQL command or SQL query which is issued to a PDW appliance, it can go, the PDW appliance can retrieve the data both from relational databases or even from Hadoop file system. So this all happens seamlessly, and we don't have to write any MapReduce jobs to interact with the Hadoop-based file system. So as I mentioned, the data moves from Hadoop into PDW appliances. Basically, it's the compute nodes, and then the data gets served back to the requester. Okay. So from this technology, it's not just limited to Hadoop, but we'll focus today here on Hadoop. Okay, so from the Hadoop point of view, so it supports all the Hadoop-based file formats like sequential files, things like that. Okay, so looking into the architecture, how it is architected, basically it doesn't use Scoop at all. Okay, so it has its own proprietary way of connecting to the nodes that and basically the data nodes in Hadoop directly, and retrieve the blocks into PDW appliance compute nodes and process the blocks based on the query. Okay, so the one key advantage of doing this way is we get the benefit of handling the data in a much more parallel way. So the compute, if you see the diagram, the compute node 1 is connecting to 4 data nodes directly and getting the data blocks into the compute nodes. Okay, so the one of the benefit of this is once the data is retrieved from data nodes into the PDW appliance, there is an internal mechanism the SQL Server implements whether to store this data in memory or whether to retrieve the data on demand connecting to Hive. So that is the decision that will be made based on the statistics or the cost based on the query execution. Okay, so let's jump on to the next slide, which will give you a little more detailed view on how this happens with small uh, syntax. These are the commands that we use in poly-based system to connect to Hadoop pool. So the first is creating the Hadoop cluster. This is to mention which cluster are basically what are the name nodes and what are the job tracker location, and registered that information in PDW as a metadata. Okay, so basically it's nothing but we are creating an endpoint to the HDFS cluster. Okay, so the next is create a file format. Okay, so so we here we'll mention what different file formats that we are going to um, handle this data. So if you see here, the input file format, we are using text input formatter, and similarly for output, text output formatter with the row delimiter and column delimiter. Okay. So now the next task is to define a table in PDW, um, actually which is stored in HDFS. Okay, so if you see here, the create external table is a new syntax in SQL side to create a table, but just with metadata, and that meta information is stored in SQL Server, um, pointing to the actual Hadoop data blocks. Okay, so the next is the location, where this location in HDFS, and here we specify which cluster to use and what data format to read this particular data. Okay, so once this is done, now the HDFS customer table is just like a regular table in SQL Server, and you can use whatever the regular operations that we normally do. So now the user is seamlessly accessing data from Hadoop. He can use joins on this table with with other relational database tables. Everything happens behind the screen. So this is another proprietary way that Microsoft claims that this is much faster to access Hadoop-based file system. So let's jump on to the next slide. So this is the Hive ODBC connectivity way of accessing Hadoop-based file system. With this, we can connect any regular or legacy applications which supports ODBC to interact with Hive database. Okay, so the from a software perspective, there are multiple commercial vendors are releasing the ODBC drivers. So now let's jump onto a small demo with Hive ODBC. For this demo, I'll be using Excel as a tool to interact with Hive, but it's not that we can use only Excel. You can use any other application to interact with the Hive and get the data into any of your relational database systems. So in a way that I can connect to use this ODBC Hive driver and write a small application, maybe in Java or in C# to connect to Hive, get the data, and push the data back into relational database systems. Okay, and now go to the sources, select Microsoft Query, select new database query. So we are establishing a new ODBC connection here. Basically, we are doing from the scratch. Use some name. And then select the ODBC driver. So here I'm selecting Hortonworks Hive ODBC driver, which I installed before this presentation, and then choose connect. Okay. So in this case, we have to provide certain values. Description is quite obvious. Okay, and then the host. So this is the host where the Hive is installed. So let me quickly jump onto my virtual machine and see what is the IP of this machine. And we are done with the VM, minimizing that. So use test connection. It's always the best practice. Yeah, it's successful, right? Select OK. Now what happens is if you select OK. Okay. So here comes the description what we use. So double click or select and open what is this. So you can see here now it's connecting behind the screens. It's connecting with the ODBC driver that we specified to Hive, and then retrieving the tables that are there in the Hive. So in this case, we have employee table. So that's how we see the employee table here as before to this presentation. Now we can choose or select the columns that we just want to import. In this case, I'm just importing randomly some numbers. And okay, basically my idea is to retrieve integers, characters, integers, and date range, something like that. Okay, and we don't need to filter anything, so we just want to retrieve everything as is. Select OK. Now it's connecting to Hive with the ODBC, and then pulls the data from Hive into the Excel. Okay, excellent. So we have the 14 records with the selected columns coming back from Hive to our Excel. So that's it. So pretty much we can do the same technology for DBC to, as I said, to write your own programming language, maybe Java or C++, and read the data from Hive ODBC, from Hive to Hive ODBC, and push it to any of your required RDBMS systems. Next is quickly walk through the prerequisites that I use to run these demos in this machine. Is so you have to install cloud. In this case, I considered installing the quick start VM from Cloudera, which, as I said, pre-installed with all the Scoop related software, Hive, Scoop, etc. And the other thing you have to install is since we are in this case, I'm connecting to SQL Server as an import in the import option. So I need to install the Microsoft JDBC driver for connecting to SQL Server. So this particular link will guide you to download the tar file, copy it to, untar it basically, and copy it to user lib, scope lib folder. So that's how you just need to paste that file in the particular location. Then we are all set to connect to SQL Server from the scope. Okay, similarly, Hive ODBC. So I installed the Hortonworks Hive ODBC driver, 64-bit for Windows 7 OS, and follow the instruction on screen instructions, and then install that to your local machine to get the data. Okay. So these are some other reference links which might help understanding the technology much more deeper. With this, thank you very much, and this is all about exchanging data between HDFS